people about the equator, how the water rotates in both sides of the equator, and how we prove that we are in the equator. Yeah. So this is the southern hemisphere, whereby rotation goes the other way and clockwise. You see the difference now. So this is how we differentiate between northern hemisphere and southern hemisphere and clockwise. Look at the bottom here also, the spiral is spinning the other way. But when you get right on the line, you'll find that no spirals, the other water spins very straight down.
Yes, hello guys, welcome back to Mtoto wa Kibokoni, and today we are also in Nanyuki, exactly roughly a year ago, because it was November 3rd, we were here, and today we are here with another man, Peter.
Yeah.
So Peter, what do you do?
I just teach people about the equator, how the water rotates in both sides of the equator, how we prove that we are in the equator. Yeah.
So that is telling us the difference between the north and the south pole.
Yeah, there is a difference between the north pole and the south pole. That's
all right.
You see right now.
Okay, but then let's do it.
So so you see the sign there?
Yeah.
That is right at the equator. You know, equator is an imaginary line which goes over from east to west. So equator divides the world into two equal hemispheres. So this side we are is the northern hemisphere, the other side is the southern hemisphere. So here we have a demonstration on now what is affected by the line of the equator when we move to the north, when we move to the south, and when we come exactly on the line. Okay. So when I pour water on the ball, let the water drain through the small hole here, you find that it rotates clockwise in the north. When we close the line, we move to the other half of the equator, it rotates anti-clockwise. And to prove that we are right at the equator, when we come exactly on the line of the equator, no rotation, the water stops and drains straight down. So to see these changes, we have to move some few meters away from the equator, that is 20 meters both sides, then you finish on the line. So let's move to the north.
Okay.
Yeah, so this is the northern hemisphere. This is 20 meters north, whereby the water rotates clockwise. And because with clear water you can't see it clearly, that's why we use this one as an indicator to show how the water is rotating. So you can see the water is rotating clockwise in the northern hemisphere, and this force or the effect is called Coriolis force. Coriolis is the person who discovered the force. That's why it was named after him, Coriolis force. And the Coriolis force happens due to magnetic force and gravitational force. So you find the same thing happens when you open water in taps and when you flush toilets, depending on the size they are located. When we look at the bottom here at the water drain, you can see it has the spirals spinning this way. These are the spirals spiraling this way. So when you go to the south, you find that they spiral the other way. And note this. The far we move away from the equator, away from 0 degrees of the equator line, the faster the water rotates. And the nearer we move toward the equator, the slower it goes. So the force becomes strong as we move away from the line, and it becomes weak as we move toward the equator. So this is what happens in the north. Now we are moving to the other side of the equator, southern hemisphere, and see what happens.
Okay.
Let's move to the south.
Kara, how are you? How are you?
Alright, so this is the southern hemisphere, whereby rotation goes the other way and clockwise. See the difference now. So this is how we differentiate between northern hemisphere and southern hemisphere and clockwise. Look at the bottom here also, the spiral is spinning the other way. But when you get right on the line, you'll find that no spirals, the other water spins very straight down.
So this is the south and
this is the south. Now we are going to the equator and see what happens. Okay?
Yeah.
So let's see exactly what happens on the equator.
There's no problem. I'm going to check.
So this is exactly on a point of 0 degrees, whereby no rotation. So here you find that unless the disturbances of wind which control the equator, go straight down.
So there's no movement at all.
No movement at all at the equator. Only the wind here disturb the indicator. Even if you try to force the indicator to rotate either way, it can't, or the other way, they can't. But when you look at the bottom here,
there are no spirals.
No spiral, just the water spins very straight. So that's how we prove that we are exactly at the center of the world, unless you have any question.
I don't think so. Maybe any other person has a question. You are doing this experiment for the second time now.
Yeah. Do you have any question?
If they don't have, ask them.
They can come from the side.
Yeah.
You can ask us.
Me, I can't ask you because I'm the teacher. I was just teaching. I can't ask you.
Check on ability to grasp it. You put it on this side, you see the difference.
We have already seen. Yeah.
Oh, huku ni north. So towards the north it goes clockwise direction. This stuff it spins clockwise. This side it spins the other
geography.
anti-clockwise. It's geography. There's no change. No, these are these disturbances of the wind.
But when you look here,
It's not straight. Unlike that side, there was some kind of spiral. So what can you deduce from this experiment?
yeah?
What can you conclude from this
From
experiment?
this conclusion, I can conclude that equator is exactly here, because we can see with the water.
Yeah.
Because when you are looking both sides of the equator, there is some rotation, but when you come to the equator, no rotation, the water stops. So in conclusion, we can prove that this is the line of the equator. Really, this is the line of the equator.
So this is 6,000. We are at
389
feet.
That's
above
in
sea
meters.
level.
In meters,
Yeah.
it's about almost 2,000. Not really 2,000,
yeah.
but almost.
Almost 2,000.
Because hapa even hapa imeandikwa. So unaona in meters 1947.4 meters.
Yes.
389 feet above sea level.
That is about just apparently 9,500 meters above sea level.
Yeah.
That is quite high. How come
That's
today is
quite
not
high.
very cold? It's normally very cold.
In the morning,
Yeah.
it was very cold.
It was very cold.
Now, not cold.
Ah. Okay. So let me go. So guys, this is remind them your name.
Peter.
So Mr. Peter just demonstrated for us the experiment which is called the Coriolis force.
Yeah.
Whereby if you move away from the imaginary line, that is the equator,
Yeah.
towards the north,
It rotates clockwise.
rotates clockwise,
Yeah.
and then towards the south, the water rotates anti-clockwise. So which means we are at the middle of the world.
Yeah.
So this is Nanyuki, and we are at about 2,000 or about 1950 meters above sea level. That's quite a distance.
Yeah.
If you are to cover that.
Yeah.
So thank you for watching this experiment. Ensure that you go to Mtoto Kibokoni and subscribe to our YouTube channel.
Thank you very much.
Tell them bye.
Welcome.
Bye bye.